Today, we are going to be doing graphing solution sets of inequalities. We will be drawing, we will be graphing, we will be making parabolas, we will be shading. Let's go ahead and jump right into it. Here we go. Basic idea. When the y variable is on the left side, the greater than signs mean you shade above, the less than signs mean you shade below. It's very logical. Take a look at this. Here's an example where the y variable is on the left. It says y is greater than, and the y is on the left. The purple line you see here, that's the function. The function x squared plus 2x plus 1 is represented by the purple line. And since all of the y values that you're supposed to shade need to be greater than the purple function, you would be shading above, where you can see the green blob right there. Likewise, if you saw the less than sign, you would be shading below the graph this time. So again, x squared plus 4x plus 4. That is the purple line you see here. And then y being less than the purple line means you shade under it, and that looks like the green area that's shaded right here. But on the spot, I'm actually noticing I made a very, very small error in this problem. It says y is less than, meaning it should not be a solid line. It should be a dotted line. That's a quick thing from Algebra 1. Let me make that look a little more dotted right there. There we go. Solid lines, when you graph them, will have the or equal to symbol with your inequality. But a dotted line, when you graph it, is just going to be the inequality without the or equal to below it. Regardless of all of that, here's one more way to also understand this and make sure you get the idea. If you had the function upside down, you had upside down parabola, that was negative. Just take a look at what things mean this time. Y being greater than a negative parabola means you still shade above, but look at how the above looks. It's basically the opposite of what you just saw in the other image. And then the same thing over here on the right. Y is now less than, but it's a negative parabola that's upside down. So less than still means under. If you follow the rules of the variable being on the left, greater means above, less means below, you'll be right every time. Let's look at some practice problems now. So this picture already has both your parabola and your linear function drawn. We're just trying to shade the solution set, where the two graphs are going to have an overlapping shaded region. Let's just make sure we understand which function is which. First, the x minus 2. It says less than, so that means you would shade under. And since it says x minus 2, well, that is a linear function. That is an x to the power of 1. We know it can't be the quadratic, the curved parabola, because you have an x to the first power. So shading underneath that line would look like this shaded region right here in red. Also take note of the fact it was the less than sign, so that is why the line is dotted right there, not a solid line. And then the second function is a parabola. You can tell by the power of 2 in the function, meaning it's going to be a parabola. You can also observe it is negative, so that means it's going to be upside down. It says greater than, so above the blue line is where you need to shade, and that's where you can see all of the blue shaded squiggly stuff that's right over there. Now for the solution set. That is always going to be where the two colors overlap, and you just have to darken in that region, and then you're going to be done. So the purple that you see right there, well, then there you have it. That's the solution set. That's basically it. Oh, went too fast. Let's just do another one, whatever. So now let's actually graph. So up until now, you haven't had to graph, and graphing isn't that hard. So let's just get right into it. You got to start by taking your function and you got to factor it. You got to factor it so you can find the zeros. And what are the zeros? Well, that's going to help you graph the first 2 points on your line. So when you do your factoring procedure correctly right here, and you use the zero product property right here, you're going to get -1 and -5 as your x's, and you can plot those right there. And by the way, if you didn't pause the video to maybe draw a coordinate plane and do this as well, you might want to do it because you're going to have to ultimately do something like this on an exam. The next part, we need to find the vertex. And you have a formula for that from Algebra 1. X equals -b over 2a. You might be asking yourself, well, where's the -b over 2a coming from? A is the 1, B is the 6, and C is the number 5. And that is where you get those values from. So when you take the correct values and you plug them into negative b over 2a, you're going to get negative 3 as your answer for the x value of the vertex. But we also need the y value. So you're going to have to take that negative 3, you're going to plug it back into the function. And when you plug it back into the function, you're going to get negative 4. You can see the work right there. Look at it, check it out, double check it, whatever. I know it's right. Now, quick thing to maybe note just before I continue, maybe you're a good visual learner. Maybe you will understand that since the vertex is always the halfway point in your parabola, you can kind of tell that the halfway point is going to fall right there through negative 3. And you won't even need to use the negative b over 2a formula. You can just observe with your eyes that from negative 5 to negative 1, negative 3 is that halfway point. And then you can just take negative 3 and plug it right back into the function to get the y value of the vertex. Because you don't know the y value, but you can tell the x value just by looking for the middle of your zeros. Unless they're decimals, then you'd have to use the formula. Whatever, carrying on. We have that function now graphed and we shaded above because it did say greater than in the problem. And now for the rest of the problem. So on the same coordinate plane, you are going to graph the line 2x plus 5, and it says y is less than or equal to that. Well, remember a little old thing called slope-intercept form, where you have a value of m being 2 over 1, and b, the y-intercept, is 5. So, looking at the graph, 5, your value for b is plotted right there. And then the slope being 2 over 1 means you rise 2, you run 1. Rise 2, run 1. And that's how you get the whole little staircase thing that's going on here. It looks a little blurry because of the highlighter, but whatever. You should know how to graph a line by now. This is Algebra 2 stuff. So you graph your line. Notice how the line is solid because it was the less than or equal to symbol. And then it says less than, so you're going to shade below the line, which would look like this. And then now we can find the solution set. And the solution set is where it overlaps. So it's that darkened black area right there. Hopefully all of this has made sense so far, so that the last question is going to also make sense. Is the point negative 4, negative 3 in the solution set? Listen carefully. This has not yet been talked about. First, just look at where the point is located. It is sitting there, the green dot you see, that is right on the solid line of the solution set. That means it's a solution. Solid line, if a dot is touching it, yes, that's in the solution set. If it were a dotted line, then no, it wouldn't be in the solution set. Now, I could just move on, but let me just show you really quickly. If the point is in the solution set, then that means you can take both the x and the y value, you can plug it into both of the functions, and you're going to get a true statement. Over here on the left, I plugged negative 4, negative 3 into the 2x plus 5, and you can see that at the end, you get the statement negative 3 is less than or equal to negative 3. Even though negative 3 is not less than negative 3, it is equal to it, which is part of the condition for making this true. This is okay. Same thing if you take negative 4 and negative 3 and you plug that into the quadratic from the original. That's right here. You get the same result. Negative 3 is less than or equal to negative 3. That is true. Once again, if the dot were not on a solid line, instead a dotted line, then this would not be in the solution set. It would be a bad point. We'll look at that concept again towards the end. Let's just make sure the graphing is good. Here we go. First, make sure the concept is there. Find the error in the shading. Please pause the video. Take a look. How should this have been shaded instead? Where is the overlap region supposed to be? And we'll just pretend like there's Jeopardy music playing right now, but I'm not going to do that in post-production. All right, so first observe that the top equation said y is greater than, and then it said negative, so that indicates that it is the upside down parabola that you see there with the red dotted line. And then we have the positive parabola, which would be the one that is in blue, opening upward, and then look at where things are supposed to be shaded. In the first one, it says greater than the negative parabola. So that would mean above, which is where the red squigglies should go. And then the second one, it says less than or equal to the positive parabola, which would be underneath. So it looks like the blue was originally shaded correctly, but it was just the red function that was not shaded correctly. So the overlapping region is on the wings of this problem, and that's where you get your solution set. Hopefully you got that one right. All right, let's do the finale problem. One for you to practice on your own, so practice it on your own. Draw a coordinate plane. This is about as involved as this concept is going to get. Factor your function. Find the zeros. Use negative b over 2a to find the vertex because you're going to get a decimal in the second example, or the second function. And then see if you can get things to graph where they need to graph. Oh, and then there's a little bonus question at the bottom. The smallest value of y in the solution set. That would be a little extra thing for you to answer. I think I'm just going to let this play through because it's the same skills that have already been done where you have to factor and all of that. So enjoy it, and maybe I'll say some words at the end. So let's just slow down the playback speed. Here we go. First, you do your factoring. You get -4, -2. You could observe that the x value of the vertex is going to be at -1, but you could also use the negative b over 2a formula, and then you would shade right above. And then the second function, you know it's going to be a positive x squared, so you first find the zeros of -1 and -4. And then, because you're going to get a decimal for the x value of the vertex, you would probably want to use the negative b over 2a formula because you get decimals, so just estimate them to the best of your abilities. And that's where the solution set falls. And then that little question at the end, the smallest y value in the solution set would be the lowest one you can find, and that actually happens at 0. All right. Hope all of this made sense. And if not, well, drop a question in the comments so that I can help and answer and all that good stuff. Thanks for watching. See you next time.